Well, hello, pre-calculus students and seekers of general truths. In this video, we will look at how to solve a problem like this, then like number 112 here in this example, with a combination, a composite of inverse function and trigonometric functions. So let's understand a little bit of what this question is asking. It's saying, let's start with the inside here, right? So the first thing in our function machine is the tan inverse function. And keep in mind, tan inverse is going to take in a ratio, and then it will produce an angle. Then we're going to take that angle and feed it into the sine function, and the sine function is going to produce negative root 2 over 2. Okay? And our question here is, our ratio here is x. So what kind of numbers can we feed into this function machine so that the result will be negative root 2 over 2. So one thing that I want to point out here is that because we're looking for the input, there could be many different answers. There could be more than one answer. But let's just unpack this one at a time. So let's just take it this phase of the function machine here. Now let's just call this angle theta. Okay, so sine of theta equals negative root 2 over 2. Now there are lots of different answers to this problem. Right? We can look at the unit circle. Negative root 2 over 2 for sine is this point, and this point plus or minus 2 pi n. Okay? So we can say, one thing we can say is, like, let's substitute here theta for tangent of x, for tan inverse of x rather. And so we can, think of this problem as like, well, sine of theta is equal to negative root 2 over 2. And there's lots of different answers for theta, right? So this could be, it could be 5 pi over 4 plus or minus 2 pi n. And it could also be 7 pi over 4 plus or minus 2 pi n. Excuse me. So this should say 2 pi n. All right. Okay. Now that we got that figured out, what that means, remember theta here is like a kind of a substitute for the tan inverse function. So now we can ask ourselves, like, if I want to get negative root 2 over 2 as my output, then I can feed any of these numbers here into the sine function. Now we can backtrack it one more step, and we can say, if I wanted to get some of these numbers, what do I have to feed into the tan inverse problem? Okay, so what do I feed into tan inverse so that I could get some of these numbers right here? Okay, maybe not all of them, but I can at least get some of these numbers right here. Well, but keep in mind that the tan inverse function, we're only dealing with the right side of the unit circle here, and the tan inverse has a range of negative pi over 2 to positive pi over 2 exclusive. Okay. So there are only so many numbers that we can feed in here for x that will produce one of these results. And in this angle right here, what we're talking about here is negative pi over 4. Okay. So the tan inverse function, if we understand it a little bit better, there's only one result that we could feed into the tan inverse function that will produce negative pi over 4, and that number is 1. Excuse me, that number is negative 1. Okay. So if we have negative 1 going into tan inverse, we will get negative pi over 2 out of there. And then if we get pi over 4 out of there, and then if we feed negative pi over 4 into the sine function, then we will get negative root 2 over 2. And this is the only solution that would work for this particular problem. So it seems like we might have a lot of solutions here because we're asking for the input, but because of the restricted nature of the tan inverse function, there is only one number that will actually work, and that number is x equals negative 1.